Hi, I'm Ann Groff, manager of the Analytics Department here at Tensile Technology. Today we're going to talk about tensile, elongation, and tear. These physical properties are measured on cured material and are key to helping you choose the right NuSil silicone material for your application. At NuSil, we test using ASTM standard 412 for tensile and elongation and D624 for tear. Tensile, elongation, and tear will tell us if a material can withstand everyday stress and strain, such as stretching, twisting, compressing, or pulling. The standard way to test tensile elongation and tear is to hold the two ends of a material and pull it until it breaks. The force required to break the material is the tensile strength. The length the material stretched before it broke is the elongation. If we nick the material and pull it until it breaks, the force required to tear it is the tear strength. This simulates the resistance to total failure with normal wear and tear. To better understand these physical properties, think of some everyday examples. Let's take cooked pasta. Here we have spinach fettuccine. When I stretch it, it doesn't take a lot of force to break it. So we would say it has low tensile strength. It also didn't stretch very far before it broke, so it has low elongation. In contrast, let's think of this rubber band. I can stretch it without breaking it, so we would say it has high tensile. And since it stretches far without breaking it, it has high elongation. Finally, to simulate wear and tear, we've nicked this rubber band. Then we pull it until it breaks. The ease at which it tore is the tear strength, and since this rubber band tore relatively easily, we would say it has low tear strength. Today we will be testing a cured NuSil silicone elastomer, which is done in our applications lab. The material was prepared into a slab for testing. For more information on how to prepare a slab, visit nusil.com. The slab was cut into a specific shape with specified dies. This die is used to cut tensile and elongation bars. This die, which has a built-in nick that introduces a defect into the sample, cuts tear bars. The two bars are tested in the same way, but the tear bar will give you information about how a sample will react when a material is defected. We test tensile, elongation, and tear using an MTS. The sample is placed into the clamps, and the instrument pulls the sample until the material breaks. The force required to stretch the material increases as the sample is stretched. The force at that exact moment that the sample breaks is reported as the tensile strength. In this case, our sample has a tensile strength of 540 psi. The length of the sample when it breaks is the elongation, and we report that as a percentage of its original size. To calculate that, we take the stretched length of 70 millimeters and subtract its original size of 25 to give us 45 millimeters. We divide that by 25 to give us 1.8. Then we multiply by 100 to report in units of percentage. This material has an elongation of 180%. For tear, we test the bar with an intentional defect. We place the material into the clamps, and the instrument pulls the sample again at a constant speed until the material tears. The exact moment that the material tears is the reported tear strength, which we give in pounds per inch. The tear strength for this material is 45 pounds per inch. We can now use these properties to help you determine what's critical to quality for your application. Take an artificial finger joint, for example. It will see a lot of stress because it's bent over and over every day, but not a lot of strain because it doesn't need to stretch very far. From what we've learned today, we know that an artificial finger joint needs something of high tensile, but not necessarily high elongation. Thank you for joining us today to learn about NuSil, tensile, elongation, and tear. We have the equipment and expertise to help you choose the right NuSil silicone material for your application.